Hey class, welcome to our Algebra 1 Plus Chapter 1 review. We will be covering sections 1.1 through 1.6, excluding Chapter 1.5 that will not be on the test. Now remember, your test is coming up next week on Thursday, and this is our first test of the year, so we want to make sure to really start off with our best foot forward. So to help you do that, I have created a little review video going over the topics that will be included on the test. Now, as a reminder, this should not be the only studying that you're doing. Hopefully you have been reviewing your notes and doing practice problems, so you know if you need a little extra help. That way you can come see me in the Math Center in the mornings or during advisory every day. So now that we've gone over how to prepare for this test and the tools to use, let's get into some practice problems. As we go through these problems, I recommend that you pause the video before watching me answer it. That way you can try it on your own first. So our first section, 1.1, was all about translating our algebraic equations and verbal expressions. So the first question states, write a verbal expression for the algebraic expression. Now, the reason we crossed out equation that was there originally is because this is not an equation. Remember we talked about how equations have equal signs? So this would be an expression. Now, when I'm translating, the first thing I do is read it to myself, and I see 15 plus 5y. I could write that, and it would be correct, but it's not our best possible answer, and we really want to push ourselves to use that vocab that we learned in class and elevate our expressions as much as possible. So instead of just saying 15 plus 5y, I'm going to write the sum of 15 and 5y. That is an awesome answer. I would love to see your answers as close to this as possible. Really push yourself to use that vocab and get the most elevated answer possible. Moving on, write a verbal expression for the algebraic equation. Now, again, I'm going to read it to myself. 7d cubed minus 12. So I know I'm multiplying 7 and d cubed, and I'm subtracting 12. So I could use a number of vocab terms to describe what's happening. 7 times d cubed, the product of 7 and d cubed. So I'm going to think about what's the best way that I could write this. And I'm going to write 12 less than the product of 7 and d cubed. So I'm utilizing my words less than and my phrase the product of in my expression. This is one of the best ways to describe this equation, but remember it's not this expression, but it's not the only answer. Moving on. Now we're going to answer some questions that are given to us in verbal written form, and we're going to write it as an algebraic expression. So write an algebraic expression for each verbal expression. It says the difference of x cubed and 12. When I see the difference of, I keep my values in the order in which they're presented to me. So I'm going to write the difference of, that's subtraction, x cubed and 12. Now another example, the quotient of 5m and 4. Now, quotient tells me that I am dividing. So I could write this as 5m divided by 4. That's fine. Or I can write it in the algebraic way in which we'll see it most often here in Algebra 1+, which is 5m over 4. This is the way I would love to see you do it on the test. Now, one more thing I want to go over, a very common misconception, or not misconception, but area of confusion is when we have the phrase the difference of or the phrase less than. For example, 12, let's separate that, less than x cubed. Now, this sentence represents the same expression. But notice how this time I put 12 first. That's because when we're talking about less than, we want to put the number that we're taking away first to show that that amount is being taken away by whatever from whatever comes next. Moving on, now we're going to evaluate expressions, section 1-2. The major key to remember when we are evaluating our expressions is to use PEMDAS, our order of operations. So I'm going to look at my equation or expression, and I am going to see what step I should do first. The first step in my order of operations is parentheses or grouping symbols. But I don't see any of those, so I'm going to move on to the next step, which is exponents. And I do have an exponent, so that's where I'll start. 2 cubed is 8. And after I write that step down, I am going to bring down everything else in the expression, making sure I don't forget any pieces. Next, I'm going to move on to multiplication and division. Now remember, these two steps are done left to right. So the order in which you read your expression, whichever comes first. So I'm going to look, I see multiplication and division, and yes, multiplication comes first in PEMDAS, but when I read left to right, division is first. So that's what I'm going to do. 48 divided by 8 is 6 times 3 plus 5. Bring everything else down. Now I still have multiplication, so that's what I'm going to do next. 6 times 3 is 18 plus 5. And now I move on to my last step, which will always be addition or subtraction. This one also is done from left to right. So I'm going to do 18 plus 5, and I get 23. Always remembering to circle my answer. Let's try another one. So again, I'm just going to write down my order of operations, so I can almost use it like a checklist. So I look and I see, first, do I have parentheses? Yes, I have 2 sets of parentheses. So I can do them one at a time. I'm going to start from left to right. 8 minus 3 is 5 times 3 times 3 plus 2. Now, now I'm going to do the second set of parentheses. 3 plus 2 is 5. Bring down the rest of the equation. And now I'm left with 5 times 3 times 5. The good news is the 5s on both sides are the same. So really any order will work. But that's also true because of our properties of multiplication. These parentheses, because there are no operations inside of them, they represent multiplication. So this is really 5 times 3 times 5. And our properties of multiplication tell us that we can multiply in any order, and we're still going to get the same result. So I'm going to do 5 times 3 times 5 is 15. And then 5 times 15 is 75. Continuing on in section 1-2, now we're going to evaluate given certain values. So this is kind of like a puzzle. They give you the pieces and you have to plug them in to the correct variables. So here we have a equals 3, so I have a in my expression, and b equals 6. Now, I don't see c anywhere in my expression, so I can just ignore that one. Now I'm going to plug in my values. 8 times b is 6 minus a is 3. From here, I apply my order of operations. So I multiply first, 48 minus 3, and that gives me 45. Let's do another one. This time we have some exponents and some parentheses in there. And we're going to evaluate if x is 4, y is 3, and z is 2. So I'm going to plug those values in to their corresponding variable. So I'm going to rewrite this. 2 times x is 4, so 4 squared, minus y is 3, plus z is 2 squared. Now I'm going to think back to that order of operations. Do I have parentheses? Yes. So I'm going to do what's inside the parentheses first. But what's inside the parentheses is an exponent and subtraction. So I'm going to do my exponent first. So that becomes 4 squared is 16. Bring everything else down. And then I look and see what else I have. Now, I have parentheses and exponents. I'm going to do the parentheses first. 2 times 13 plus 2 squared. I still have parentheses, but those are really just signifying multiplication. So I've done my parentheses. Now I move on to my exponents. 2 squared is 4. Bring down the rest of the equation. Then I'm going to do my multiplication. 2 times 13, that is 26, plus 4. And then last step is to add. 26 plus 4 is 30. All right. Some more from section 1-2. Go ahead and pause the video if you haven't been doing so already and try this one on your own. When you're done, press play and we're going to go over it together. So we have a equals 4, b equals 6, c equals 8. I'm going to plug those in for a, b, no c, so I can just ignore that one. So it will be 2 times 4 plus 6 squared divided by 3. Thinking about my PEMDAS, I'm going to do parentheses first. This parenthesis is just multiplication, so it doesn't really apply, but this parenthesis has an operation inside of it, so that's what I'm going to do. Now, I have exponents and division, so I'm going to evaluate the exponent first. 6 squared is 36. Bring down the rest of the equation, showing all of my steps to make sure I don't lose any points. And then I'm going to continue on within the parentheses. So 36 divided by 3 is 12. Bring down everything else. Now, I'm done with my parentheses. I don't see any exponents. So next is multiplication and division. That means I'm going to do 2 times 4. That's 8. No more multiplication and division. So last is addition and subtraction. 8 plus 12 is 20. All right, great job, guys. Keep going. If you need a break, take a break anytime. We're going to continue on now with a word problem, applying what we just practiced. During a long weekend, Devin paid a total of X dollars for a rental car so he could visit his family. He rented the car for 4 days at a rate of $36 per day. Well, remember, per reminds me that I am going to be multiplying. Now let's continue. There was an additional charge of 20 cents per mile. Again, the word per tells me I will be using multiplication. But before I figure out how, let's finish reading our question. 20 cents per mile after the first 200 miles driven. So write an algebraic expression to represent how much it would cost Devin to rent a car for 4 days and drive a total of 350 miles. So there's a couple steps we have to do here, which is why PEMDAS is going to be so important to make sure that whoever's solving our equation does the steps in the right order to get the same answer that we get. So I see he's renting the car for 4 days at a rate of $36 per day. So I'm just going to write 4 times 36. Now, I don't know if I'm going to need to move that around somewhere else in the equation, so I'm just going to put it there for now and continue reading. Then there was an additional charge of $20 per mile. So that'll be plus $20, sorry, 20 cents. That would be very expensive. So that would be 0.20 per mile after 200 miles have been driven. So for every mile after the first 200. Now, he's driven the car for 4 days. We already have that accounted for here. And he's driving a total of 350 miles. But I'm not going to put 350 here because he's not paying for the whole 350. He only has to pay for the miles after the first 200. So for M, we're going to rewrite this as 350 minus the 200 miles that are free. We're still going to multiply that answer by the 20 cents per mile and then add that to the $36 per day he will be paying for 4 days. So that would be my expression. If I evaluated it, I could find out exactly how much he is paying, but they just wanted me to write the expression. All right, last question from section 1-2. The length of a rectangle is 3n plus 2. Now, rectangle tells me that I'm working with a quadrilateral, and this is the length of it. And the width is n minus 1. The perimeter of the rectangle is twice the sum of its length and width. There is my algebraic expression. My verbal expression. So I need to remember how we translated that to an algebraic expression. Twice the sum. So that'll be 2 times the sum of something. And it's 2 times the sum of the length and the width. But here's where things get a little bit funky. The length is not just a number, it's an expression, which would be 3n plus 2. And the width is n minus 1. So I need to write an expression that has these 2 expressions in the place of the L and the W. So I'm going to turn that into 2 with brackets because I'm going to be using parentheses to separate these 2 measurements. And I don't want them to get too confusing with parentheses inside of parentheses. So the brackets and then the parentheses, 3n plus 2 plus n minus 1, close brackets. That would be my algebraic expression. So then the last part, they want us to find the perimeter of the rectangle when n equals 4. So that expression we just wrote, 2 times 3n plus 2 plus n minus 1. Well, I'm going to replace the n with the 4. So 2 brackets 3 times 4 plus 2 plus 4 minus 1. So 2 times 3 times 4 is 12 plus 2 plus 4 minus 1 is 3. Now I ran out of room and I want to make sure to stay organized, so I'm going to move it over here. 2 times 12 plus 2 plus 3. So now I'm going to solve what's inside the parentheses. 14 plus 3. That's 2 times 17. 2 times 17 is 34. So the perimeter of the rectangle is 34 inches. If it's area, remember we put inches squared. All right, now section 1.3 was all about our properties of real numbers. So we're going to name the property that best represents each equation. Now, the first one is 8 times 3 equals 3 times 8. So this is an example of the commutative property of multiplication. I know that because I'm multiplying and the two sides of the equation are showing me the same values just flipped around. They have been moved. They have been on a commute. So, commutative property of multiplication. The next one I see 5 plus 2 plus 4, 5 plus 2 plus 4, but the difference is the location of the parentheses. So that is telling me that the difference is the grouping. And when I think about grouping, I think about associating with different groups. So this would be the associative property of multiplication. All right, so now the next one is A times 1 equals A. So I notice I have the same value I started with as my answer. So that tells me that I'm keeping the same identity. So this is the identity property of multiplication. My next example, 3 times 7 plus 6 in parentheses equals 3 times 7 plus 3 times 6. I've distributed my multiplication across my addition. So this is the distributive property. Now here we have 4 plus 0 equals 4. So the 4 plus 0 equals 4, that is our 0 property. The next one, if A equals B and B equals C, then A equals C. Here we are making a conclusion. They're telling me that A and B are the same and B and C are the same. So that means A and C must be the same. A and B are the same. B and C are the same. So that means A and C are the same. This is the transitive property. And the last one, if A equals B, then B equals A. We're just flipped around with variables. So this would be the reflexive property. So I would go back and review your notes about your properties, just to make sure that you can identify which is which. Let's move on to 1.4. So in section 1.4, we are now applying the distributive property. So we want to remember that distributive property is the distribution of multiplication across our addition or subtraction. All right? So let's distribute. 5 times 4x is the first distribution, so that would be 20x. 5 times negative 9, keep the negatives, that gives me 45. Negative 45. Now, I cannot combine the 20 and the 45 because they're not like terms. The 20 has the x attached. So I'm going to circle that. That is my final answer. I have simplified it. Next up, we have 8 times 6 minus 1/2 x. Do not get scared of the fraction. They don't bite. I'm still going to distribute the same way. So 8 times 6 is 48. And then 8 times negative 1/2 x. Well, 8 times 1/2 is the same as 8 divided by 2, which I know is 4. So this is negative 4x. Next up, now we have some x's and y's. So 10xy minus 4xy, or 4 times xy plus xy. So I'm going to distribute the negative 4 to both terms inside the parentheses. So this would be 10xy minus 4xy plus, I'm sorry, don't mistake the symbols. I could leave it as a plus, but it's plus negative 4xy. So I'm just going to write minus 4xy. Now, I combine like terms because these are all xy's. So first I'm going to do 10xy minus 4xy. 10 minus 4 is 6xy. Then minus 4 more xy's. So 6xy minus 4xy is 2xy. And that would be my answer. Moving on to some more fractions. Remembering that the denominator is really your divisor. So this is 1/4 times 16x. That's the same as 16x divided by 4. So 16 divided by 4 is 4, then the x. 1/4 times negative 12y. 12 divided by 4 is 3, so that's negative 3y. And 1/4 times 4z, well, 4 divided by 4 is 1, so this is just plus z. Now I don't have any like terms. X, y, and z are all different, so that's my simplified answer. Next up, we have 3 terms inside the parentheses, again, but we still distribute the same. So 2 times 3x is 6x, 2 times 2y is 4y, and 2 times negative z is negative 2z. Now the last one might look a little bit different. our coefficient is at the end of the expression, but I'm still distributing the same way. So I'm going to go all the way over to my first term. 3 times 2 is 6. Then the next term is negative 3x. So negative 3 times 3 is negative 9x. And then 3 times x squared, which is positive 3x squared. Now, you might be thinking, okay, x and x, I can combine those. Great, like terms, awesome. No, don't be fooled. This isn't just x, this is x squared. That's its own term. So I can't combine these. So this is how I would leave it. All right. Let's move on to section 1.4. Write an algebraic expression for each verbal expression. Then we're going to simplify it. So now we're combining everything we've been doing. We've been doing some great stuff, but let's think back to our vocab. 6 times the difference of 2a and b, comma, increased by 4b. So 6 times the difference of 2a and 4b. Remember, if it's difference of, we leave it in this order. So 2a minus b. I think I said 4b. That was a mistake. 2a minus b. Then it's increased by 4b. That would be my verbal or my algebraic expression. Now they want me to simplify it. So that would be 6 times 2a minus b plus 4b. Distribute. 6 times 2a is 12a minus 6b. And then I bring down the plus 4b. Now the a and the b I can't combine, but I do have like terms here. These two b's can be combined. Negative 6b plus 4b is negative 2b. So my final answer is 12a minus 2b. The last one in this section, 2 times the sum of x squared and y squared increased by 3 times the sum of x squared and y squared. All right, this is a long one, so I'm going to take it one step at a time. 2 times the sum of, well, the sum of what? X squared and y squared. Increased by, so that's addition, 3 times the sum of, so I'm adding again, x squared and y squared. All right, so now I have my expression. Now I simplify it. I see parentheses and a coefficient outside of them. So I'm going to distribute my multiplication across my addition. So 2 times x squared is 2x squared. 2 times y squared is 2y squared. 3 times x squared is 3x squared. And 3 times y squared is 3y squared. Now, we want to look for like terms. So I have x's and y's. I cannot combine all of them. The good news is they are all either x squared or y squared. So I can combine some of them. First, I see I have 2x squared plus 3x squared. So that'll be my first step. 2x squared plus 3x squared is 5x squared. And then I have 2y squared plus 3y squared. So that's positive 6. Oops, sorry. 2 plus 3 is 5y squared. So my final answer is 5x squared plus 5y squared. Alrighty, moving on to 1.6. We're almost done, folks. You're doing great. Now, 1.6, we want to talk about our relations and our independent and dependent variables. So let's remember our independent variables are our domain, and the dependent variables are the range. Now, the domain is are the x values and the range is the y values. So let's look. Identify the independent and dependent variables for each relation, then describe what is happening in the graph. Oops, that's the wrong directions. So we are going to ignore those directions and let's look at a set of data. A set of ordered pairs, which would be a relation. So we have 3, -2, 2, -3, and 3, 4. So we want to see if this set and this relation represents, or we just want to see what is happening. That's all. So we want to first plot it. So 3, -2, then 2, -3, and the last one is over 3 up +4. All right, so there's our graph. That's how we would represent that first relation. Then we want to put it in a table. So I'm going to put my x values on the left, my y values on the right. So that'll be 3, -2, 2, -3, and 3, 4. Now the last one is a mapping. Now the only thing about a mapping to remember is that you can't repeat values in the same range. You want to show them with the lines, show that they repeat more than once. So each x should only be there once, and each y should only be there once. And then the arrows will show if they represent more than one term in the relation. So first I'm going to start with my x values. That's 3, 2, and 3 again. So I'm going to leave that 3 to represent both of them. And then my y values are -2, -3, and 4. Now to map it, I'm going to show that the first 3 is paired with the -2. The 2 is paired with the -3. And then the last ordered pair is 3, 4. So I'm going to use the same 3 and show that this time it's paired with the 4. So that is my mapping. That's how you would represent a relation. Now, identify the independent and dependent variables. So that's our x's and y's, our domain and range for each relation. And then describe what is happening in the graph. So remember, the independent variable is always going to be the x value. It's the thing that is independent. It kind of is on its own. It's not affected by any other piece of the equation. So in this case, it says the graph represents the balance of a savings account over time. So the independent variable that is not affected by anything is time. Time will always be independent because we can't change that, at least in terms of a relation like this. So as the time increases, the balance in the account changes. So that means the dependent variable, the range, represents the account balance. Okay, so that's 1.6. The last section, our most recent section, is section 1.7. We want to determine whether each relation is a function. So first we see they've shown us two graphs, and to see if a graph is a function, we use the vertical line test. So I'm going to draw my vertical lines on my graph like we learned in class, and I'm going to see if any of the vertical lines intersect through more than one point. And each of these vertical lines has only 1 point on it. So this would be a function. Now the next graph, do my vertical line test. It also intersects each vertical line only once, so this one is also a function. Now, an example of a graph that wouldn't be a function, just for a reminder, would be something like this. Because once I draw that vertical line through it, it crosses the vertical line once here and again here. So this would be not a function. All right, and the last one is a mapping. Now, mapping is my personal favorite way to identify a function, just because it's kind of made easier for me with the use of the arrows. Now, the arrows show me each range value, each y value that is paired up with an x value. And to be a function, we know that each x value has to have an independent y value and only one y value. So if x is -1, this mapping is telling me y would be 4. But then the fact that there's a second arrow pointing to the -1 tells me that if x is -1, then y would be 5 as well. Well, that doesn't work in math. The math ain't mathin', because if -1 is x and y equals 4, and I'm using the same function, then when I use -1 as x again, I should still get the same answer. That's the purpose of a function. So the fact that when x equals -1, y could be 4 or 5, that tells me that this is not a function. Now let's look at the ordered pairs. So again, remember, we want to have each x needs to have its own independent variable, or y variable. So the best way for me to see this is to first look and see if any of my x's repeat, because that's my first clue that they might have different y's. And in this one, none of the x's repeat. So this would be a function. Now, in this ordered pair, I do see repeating numbers. So let's put it in a table to see it better. We've got -1 and 0 and +1 and 0. Now, if I put -1 into the equation and get 0 and 1 into the equation and get 0, that is possible, because the equation might affect my x variable differently depending on what the equation is. So in this case, this would also be a function. Now the last one, we have -3, -3, -2. Now I see that I have two -3s. So now I need to check, do they have the same y or do they have different y values? And here, well, one of the y values is -3 and the other one is 4. They are not the same y value. So that means that this relation is not a function. So that's how we identify our functions. For the last section or part of section 1.7, we are going to now evaluate or find the value of each function, given the function and the value we're using for f or g, depending on what the name of the function is. So here they've given us two functions, f of x equals 2x minus 4, and g of x equals x squared minus 4x. So when we are solving a function like this, the number in parentheses tells me what f needs to be represented as in the equation. So whatever's in the parentheses, I'm going to plug into the function in the place of the x. So this first one, my equation is f of x equals 2x minus 4, and f is 4. So I'm going to rewrite this as 2 times 4 minus 4. 2 times 4 is 8 minus 4. 8 minus 4 is 4. So f of 4 equals 4. Now the next one, I want to pay close attention because this time it's g of x. So I'm going to use a different equation. Luckily, they will always give you the function equation, the function. So g of x, they've told me, is x squared minus 4x. So we're going to replace the x's with 1/4. Now this time there's 2 of them. So this would be 1/4 squared minus 4 times 1/4. 4x squared minus 4 times 1/4. All right, I want you to pause the video now and see if you can figure this one out on your own. Because yes, there are fractions, but I bet you could do it. Let's try it together. So first we have 1/4 squared. So that's going to be 1/4 times 1/4. Now, and then we're going to do minus 4 times 1/4. So that would be 1/16 minus 4 times 1/4. That's the same as 4 divided, oops, sorry guys, 4 divided by 1/4. So that is, or 4 divided by 4, so that is 1. Now we have 1/16, 1/16 minus 1. So let's think about how we would do that. That's really 1/16 minus 16/16. So that would be 1 minus 16 is negative 15. 16 minus 16, well, we don't do that because that's when we are adding or subtracting fractions, we leave the base the same. So this answer, g of 1/4, would be negative 15/16. Now, that one might have felt a little tricky. That's one of our challenge problems. So let's try that again with a version more like what you will see on the test. Although it's good to know this because you never know when there will be a bonus question. So let's try this again, but this time let's do g of x equals 2x minus 4. So, and we're going to use the same g of 1/4. So g of 1/4 equals 2 times 1/4 minus 4. That's 2/4 minus 4, 1/2 minus 4. So that would be negative 3 and 1/2. Now I'll give you a spoiler, there won't be fractions on the test in very many questions. So while this is important to know, it's only going to be a few questions. This I want you to feel super comfortable with, all right? And if you're having trouble with this, that's okay, because you can either come see me or go to the Math Center for extra help before the test. All right, guys, that's it. We are done. So, great job. I am proud of you for watching the whole video. This one was a little bit long, but that's because we learned so much. So I just want to wish you good luck studying, and I look forward to seeing you this week in class. Have a great rest of your weekend.